Walk into almost any classroom today, and you will see students working to recall exact dates, names, and isolated facts. They are testing their memory, even though any of those students can pull up that exact same information on a smartphone in about 2 seconds. This approach to education isn't an accident. The traditional school model was designed during the industrial era. The goal was to build efficient human data storage units to serve a standardized workforce. This school system grading blueprint identifies this flaw as the memorization trap, noting curriculums heavily reward short-term recall over understanding. Moving down, it highlights that grades frequently measure surface-level mechanics, like perfect spelling, rather than if a student grasps underlying concepts. This setup creates friction across the board. Educators lose up to half of their working hours manually grading repetitive assignments, while students are given every incentive to cram for a test or game the system just to secure a passing mark. When an educational model relies on these surface metrics, it confuses basic compliance with deep comprehension. We end up measuring how well a student follows instructions instead of testing whether they know how a system works. To solve this, education has to treat information differently. As this diagram shows, we can stop viewing static, isolated dots of data as the end goal. Detailed facts serve as reference materials, the raw inputs for a structured network of knowledge. The goal is reached when a student looks at that network and recognizes cause and effect loops, structural relationships, and patterns that apply across different fields. Testing this kind of network thinking requires smart assessment. Instead of relying on multiple-choice quizzes, students are given open-ended, real-world challenges that require active thought. The blueprint provides a concrete example of this modern assessment. An open-ended challenge reads like this: analyze why a major historical empire collapsed, identify the core internal weakness, and explain how that same structural weakness could cause a modern organization or project to fail. A student cannot simply memorize their way through that prompt. They have to extract the structural failure of an empire from their historical reference material, and then prove they understand the mechanics of that failure by mapping it onto a modern scenario. To grade responses like this efficiently, modern AI models evaluate the architecture of thought. They are designed to assess the structure of an argument rather than just checking for keywords in an answer key. Looking at this section of the blueprint, we can see exactly how the AI evaluates this architecture, starting with causal depth. The system checks if the student successfully linked historical events to their resulting consequences. Next, it evaluates structural coherence, testing the actual soundness of the argument connecting the empire to the modern organization. A key feature is how the system handles surface friction. This refers to the mechanical mistakes that traditionally drag a student's grade down, things like misspelled words, poor grammar, or unconventional phrasing. Advanced AI can bypass that surface noise. Because every mind processes information differently, the system evaluates visual thinkers or neurodivergent students based on the strength of their logic, regardless of the style in which they express it. If a student attempts to copy another's response, the AI uses anomaly detection. It scans the submissions and alerts the teacher if two papers share an identical logical footprint, even if the phrasing has been changed. This application of AI clears away the administrative noise, leaving the student's actual reasoning exposed for the educator to see. When an identical logical footprint is flagged, the disciplinary process shifts. Instead of delivering a rigid automatic 0, the system prompts a flag and sit-down approach, bringing the student and teacher together for a conversation. By asking the student to walk through how they came up with their comparison, a teacher can distinguish maliciously copied work from shared study. The potential disciplinary action becomes a supportive coaching session. Looking at Part 4 of the blueprint, the benefits are clear. Students no longer face rote memorization, receiving immediate feedback while concepts are fresh. For teachers, automating administrative grading reclaims up to half their workday. Reclaiming those hours allows educators to return to the core of their profession. They have the energy to mentor, guide, and inspire their classroom. The blueprint concludes by framing this as an inclusive pipeline. Decoupling mechanical errors from logical patterns helps schools move past compliance-driven sorting to better accommodate how students process information.